The 4 Electronic Flight Instrument System EFIS displays provide the pilots with flight data to help them operate the aircraft in a safe and efficient way. Flight parameters are displayed on primary flight displays, PFD, while navigation data is displayed on navigation displays, ND. Each pilot has an EFIS control panel to select what is displayed on the EFIS screens. The EFIS control panels are divided into 2 sections, one section associated with the PFD and the other with the ND. The Flight Control Unit, FCU, is located in the middle of the glare shield. The FCU is one of the interface units between the pilots and the autoflight system. There are selectors on the FCU which will affect the indications seen on the PFD and ND, and it is only these selectors that will be discussed in the EFIS modules. The selectors with associated indications are provided for speed, heading, altitude, vertical speed. The metric altitude push button is also part of the altitude area. This push button is used to display the selected altitude in meters on the permanent data part of the system display. As an option, the selected and actual altitudes in meters on the PFDs. The 2 chrono push buttons located on the glare shield control the associated chronometer display on the NDs. The push buttons operate like a normal stopwatch. In this module, we have introduced you to the Electronic Flight Instrument System. In the next modules, we will look at the PFD and the ND in greater detail. The PFD displays all the normal primary flight indications: attitude, airspeed, altitude, vertical speed, heading and track. Notice that the indicators are laid out in a classic instrument T configuration. The PFD also displays other information. The upper part of the display is used to provide information to the pilots associated with the Flight Management and Guidance System, FMGS. The area is known as the Flight Mode Annunciator, FMA. You will learn more about the FMA in the Autoflight modules. A Flight Director FD push button on the EFIS control panel enables the pilots to switch the Flight Director display on. Notice that there is an indication on the FMA when the FDs are switched on. Caution: both FDs must be switched on or both off. You should never fly with only one Flight Director selected on. When below 2,500 feet, a digital radio altimeter is displayed. In this module, we will concentrate on the primary flight indications. Let's start with attitude. Attitude information is shown at the center of the display. The attitude indicator works in the normal sense. The aircraft is represented by 3 black and yellow symbols which remain fixed. There is a graduated scale for pitch angle above and below the horizon. Bank angle is displayed at the top of the indicator. Each graduation represents bank angle of 10 degrees. The roll index triangle moves against a fixed scale to show the bank angle. To show both the pitch and bank indications in use, let's look at the indication for a climbing turn. In this example, the aircraft is in a 20-degree banked turn to the left, with a nose-up pitch attitude of 10 degrees. Below the roll index is the side slip index. This index moves to indicate lateral acceleration on ground and side slip in flight. It replaces the old-fashioned slip ball. When this index is centered with the roll index, the side slip equals the side slip target for optimum aircraft performance. The pilot flying must use pedals to reduce side slip to 0. If the base of the pyramid is to the left, use your left foot to center the pyramid. If the base of the pyramid is to the right, use your right foot to center it. When the Flight Director FD push button on the EFIS control panel is selected, Flight Director indications are superimposed onto the attitude indicator. In the example shown, the Flight Director is centered. The vertical line is the Flight Director roll bar, while the horizontal line is the pitch bar. Let's look at an example of the Flight Director in use. In this example, the Flight Director is directing a pitch up and roll to the right. Once the aircraft has achieved the required pitch and bank, the Flight Director bars will once again be centered. Now let's look at the airspeed indications on the PFD. The speed scale moves behind a fixed yellow reference line and triangle. In the example shown, the indicated airspeed is steady at 250 knots. When the aircraft is accelerating or decelerating, a speed trend arrow appears. This arrow shows the value that will be attained in 10 seconds if the acceleration remains constant. In the example shown, the aircraft will decelerate to 240 knots in 10 seconds. The use of the speed trend arrow will be demonstrated during your simulator training. When the Flight Management and Guidance System, FMGS, is controlling the airspeed, a magenta target airspeed triangle appears. This is normally referred to as the managed speed. In the example shown, the managed target airspeed is 240 knots, and the aircraft is decelerating towards that speed. If the target airspeed is selected manually, a blue triangle appears. This is normally referred to as selected speed. In the example shown, a selected airspeed of 260 knots has been set, and the aircraft is accelerating towards it. Manual speed selection is achieved by a rotary selector on the Flight Control Unit FCU panel. Just above the selector is the indication of the selected speed. As a general rule on the PFD, a magenta indication means managed and a blue indication means selected. You will see this in the examples that follow. To look at the various other indications on the airspeed scale, we will run through a typical flight profile. We will assume a departure with the flaps in position 2. You will learn about the various flap and slat configurations in the flight control modules. During the takeoff roll, a blue decision speed, V1, and a magenta V2 speed are shown. Notice that since these speeds are beyond the visible scale, they are shown as numbers. As the takeoff progresses, V1 and V2 indications appear on the speed scale as a blue 1 and a magenta triangle. Just after liftoff, the magenta target speed remains at V2. The speed demanded by the flight director will be V2 plus 10 knots. The minimum flap retraction speed is shown by a green F. This is referred to as F speed. The flap limit speed, VFE, is shown by a red and black strip at the top of the speed scale. At acceleration altitude, the target speed jumps to 250 knots, and the aircraft is accelerated towards that speed. Notice that, since this speed is beyond the scale, it is shown above the scale as a number. The aircraft is now above the minimum flap retraction speed and accelerating. The flaps can now be retracted to position 1. The F speed indication is replaced with an S speed indication. This is the minimum slat retraction speed. Notice that the VFE has increased to reflect the limiting speed for flap position 1. The aircraft is now above S speed and accelerating, so the flaps can be fully retracted. After flap retraction, the aircraft is clean, therefore no VFE is indicated. The aircraft stabilizes at 250 knots. Notice that the target speed is in line with the speed reference line. When cleared to accelerate to climb speed, the target speed jumps to approximately 300 knots. Once again, the speed trend arrow appears. Once the speed has stabilized at climb speed, the red and black Vmax indication could be visible, depending on different conditions, weight, altitude. Below approximately 25,000 feet, the Vmax indication is fixed at 350 knots to represent maximum operating speed, VMO. A Mach indication appears below the speed scale once the speed is above the equivalent of Mach 0.5. Above approximately 25,000 feet, the Vmax indication becomes the airspeed equivalent of the Mach limit speed, MMO, Mach max operating speed, Mach 0.82. In the example shown, the aircraft is cruising at Mach 0.78, and the indicated Vmax of 300 knots represents the equivalent of Mach 0.82. A green circle indicates the best lift-drag ratio speed for the aircraft in clean configuration. This speed is known as green dot speed. During an FMGS computed, managed descent, the single triangle is split into two to give a speed range. A double magenta bar indicates the target speed. In the example shown, the target speed is 325 knots. The speed will vary between the two speed range indicators as the aircraft maintains the required descent profile. Managed descent profiles will be studied in depth in the autoflight modules. Following initial deceleration to 250 knots, there is an indication of the next flap limiting speed, VFE next. In this case, the next flap setting is 1, so an indication is shown at 230 knots. The VFE next indication will be visible provided the aircraft is below 15,000 feet. Green dot speed may also be visible. When FM approach phase is activated, a further deceleration to green dot speed takes the airspeed below the VFE for the first flap selection. Flap 1 can now be selected. Notice that a target speed of 130 knots has appeared. This represents the approach speed target. Once the flap lever is in position 1, S speed, VFE next, and the flap limit speed indications will appear. The speed will decrease towards S speed. Notice that at S speed, the aircraft is below the limit speed for the next flap setting, VFE next. Flap 2 can now be selected. As soon as the flap lever is in position 2, S speed is removed. F speed and a new VFE next indications will appear. The flap limit speed will move to a new limit. Notice that the approach speed target, V approach, has now appeared as a magenta triangle. The aircraft will continue decelerating towards F speed. By reducing towards F speed, the aircraft will be below VFE for the next flap setting. As before, VFE next and VFE move to reflect the new flap position. Flap 4 can now be selected. The aircraft will eventually stabilize at V approach, and the VFE will be adjusted to reflect full flap. There are indications associated with speed and angle of attack protections. These protection indications will be discussed in the flight control modules. Once the aircraft lands, all additional speed indications are removed, apart from the speed trend arrow. Having thoroughly studied the airspeed indications, let's look at altitude indications. All the indications associated with altitude are located on the right-hand side of the PFD. The main part of the display is dedicated to the altimeter. To the far right is the vertical speed display. We will look at the altimeter indications first. The middle part of the altimeter contains a green digital altitude readout. The red ribbon to the right of the altitude scale represents the ground reference. The ribbon is currently level with the center of the scale. Like the airspeed indication, a grey analog altitude tape moves behind the digital display. In this example, a target altitude of 5,000 feet is displayed. On the FCU is an altitude selector with an indication of the selected target altitude. At the bottom of the altimeter is an indication of baro reference. In the example shown, the QNH is 1020 hectopascals. The baro reference setting is achieved by a selector with associated indication on the EFIS control panel. It is possible to change the baro reference display to inches of mercury by rotating an outer selector. To look at the various other indications on the altitude and vertical speed scales, we will run through a typical flight profile. The aircraft is on the ground just prior to takeoff. Notice that with a QNH of 29.92, the altitude indication is 10 feet. If there is an altitude constraint set in the FMGS, then this will be shown by a magenta target altitude. In the example shown, the constraint altitude is 3,000 feet. In this example, the aircraft has just got airborne. Notice that the vertical speed indication is showing a climb of 3,400 feet per minute. As the constrained altitude is approached, it appears on the scale with a target box. Once past the constraint, the aircraft can climb further, so a new target altitude is selected on the FCU. The aircraft has now been cleared to flight level 330, so the new target altitude has been set. On passing the transition altitude, the standard pressure setting can be set by pulling the baro reference knob on the EFIS control panel. Notice that the baro reference indication has changed to standard, and the target is now shown as a flight level. The aircraft is now cruising at flight level 370. Notice that the target flight level box is in the middle of the scale, and the vertical speed indication is at 0. We are now in the descent phase. The target flight level is magenta because the aircraft is in a managed descent with a constraint at flight level 100. Because the vertical speed is high, it is displayed in amber. At the transition level, the baro reference is set to show QNH by pushing the baro selector knob on the EFIS control panel. In the final stages of an approach, the ground reference ribbon will reappear, along with a landing elevation line. Notice that the vertical speed indication is showing a rate of descent of 800 feet per minute. Also notice that the missed approach altitude has been set at 9,000 feet. When the aircraft lands, the ground reference ribbon is in the middle of the scale, and the vertical speed indication is at 0. We will now look at the compass scale. The compass display is very conventional. The grey scale moves against a fixed yellow line which represents the center line of the aircraft. In the example shown, the aircraft is heading 091 degrees. The small green diamond represents the aircraft track, and it is normally referred to as the track diamond. In the example shown, the track is 094 degrees, which means that the aircraft has 3 degrees of drift to the right. A selected heading may appear either as a blue figure on the appropriate side on the compass scale or a blue triangle. On the FCU, there is a heading selector with an indicator that is linked to the selected heading indication on the PFD compass. There is a direct relationship between the small white ticks on the horizon line of the attitude indicator and the compass scale. As the heading changes, the ticks move to stay in line. Now let's look at how ILS information is displayed, and in particular concentrate on the compass scale. The ILS push button on the EFIS control panel enables the pilots to switch on an ILS display. On the bottom left corner of the PFD appears ILS identification, ILS frequency, and sometimes distance if the ILS has a DME. ILS deviation information is displayed in the form of localizer and glide slope deviation scales. The ILS front course will be displayed in magenta at the side of the compass scale, if the figure is outside the visible scale. A magenta diamond represents the localizer. When the ILS front course is within the compass scale, it is displayed as a magenta dagger. In the example shown, the aircraft is established on the localizer, and the glide slope indication has appeared in the form of a magenta diamond. The aircraft is now fully established on the ILS approach. Let's look at the indications on the compass scale in detail. With the aircraft established on the localizer, the heading is 230 degrees. The track diamond is showing 3 degrees of left drift. The ILS front course dagger is beneath the track diamond. You will see how useful the track diamond can be to help you fly an accurate approach in the simulator phase. You will be given more information on the ILS system, the flight director, the radio altimeter, and the flight mode annunciator indications later in the course. Now let's look at another useful indication available on the PFD, the Flight Path Vector, FPV, called the bird. The Flight Path Vector can be displayed on the PFD by pushing the Track Flight Path Angle button on the FCU. It shows you what the aircraft is doing in relation to the world. It is an indication of the aircraft flight path. It is not a director. The green symbol, sometimes called the bird, represents the aircraft. The attitude indicator represents the world. Let's look at the flight path vector in a bit more detail. To begin with, we will look at the indication for an aircraft in level flight with no drift. For training purposes, we will exaggerate the angles. The aircraft heading and track are the same, so the flight path vector and the track diamond are in line with the heading marker. These indications mean that the aircraft is not drifting. The aircraft is flying level with a pitch attitude of 9 degrees. The flight path vector is on the horizon line, so at present the flight path angle is 0, i.e. the aircraft is in level flight. Now let's enter a descent and see what happens to the flight path vector. The flight path vector will move down to indicate the angle at which the aircraft is descending through the air. This is known as the flight path angle, FPA. Now let's introduce some drift to the left. As a result of wind from the right, the aircraft is drifting to the left. Let's now look at a typical example of how the flight path vector indication would look for an aircraft established on an approach. The aircraft is fully stabilized in final approach. Notice that the flight path vector is in line with the track diamond, indicating left drift. The flight path vector is below the horizon line at a 3-degree descent angle. The navigation display, ND, can present the pilots with a lot of useful data to assist in the safe operation of the aircraft. Because the ND gives the pilots a visual presentation of where the aircraft is in relation to airfields, nav aids, etc., the operation of the aircraft is also made easier. In this module, we will use the captain's ND. There are 5 display modes available on the ND. They are selected by the mode selector on the EFIS control panel. There are 3 basic navigation display modes, which display in the background a 360-degree compass rose. Note, for training purposes, the other information has been dimmed. A 90-degree segment arc, a map plan with the north at the top. Before moving on to look at the individual modes, let's quickly look at some common information. The ground speed GS and the true airspeed TAS are permanently displayed on the top left corner. Below the speed indications is the wind data, wind direction, true north, wind speed, and an arrow to indicate the wind direction with respect to magnetic north. Here, wind from 60 degrees at 52 knots. The aircraft magnetic heading is given by a fixed yellow lubber line against the moving compass rose. The selected heading or track, if bird is selected on, is shown by a blue triangle or blue numbers if out of display range. This is similar to the PFD. Actual track is depicted by a green track diamond. Range marks are displayed by white dotted lines, while range values are depicted in blue. The display range can be adjusted using the range selector. You can now see more of your flight plan and that the range values have changed accordingly. Let's study the ND individual modes. The ROSE ILS mode is a raw data mode providing standard localizer and glide slope deviation bars. Other information is displayed to assist you. An ILS course pointer, ILS information. The ROSE VOR mode is another raw data display. On the display, there is now a course pointer and a lateral deviation bar for the VOR. In this case, VOR 1. To have this display, a course must have been selected on the MCDU radio navigation page. Like ROSE ILS, the information about the tuned frequency, the selected course, and which nav aid, here Papa Alpha Sierra, is displayed in the top right-hand corner. Let's now display the VOR bearing pointer. Notice that there is a white VOR bearing pointer and VOR information associated with the pointer. This information is available even if a course hasn't been selected on the MCDU radio navigation page. The number 1 pointer is represented by a single line. Let's change the selection on the EFIS control panel to display ADF1 instead of VOR1. The white VOR bearing pointer has been replaced by a green ADF bearing pointer. The VOR information on the bottom left of the display has been replaced by ADF1 information. Notice that the selection of the pointer has not removed the deviation information for VOR1. Now let's display the ADF2 bearing pointer. The ADF2 bearing pointer is now displayed represented by a double-lined arrow. At the bottom of the display, there is information on the selected nav aids. Notice that in common with most things on the aircraft, it is number 1 on the left and number 2 on the right. Notice the tiny underlined M beside the nav aid information, which indicates that each ADF has been manually selected by the pilots. You will learn more about the nav aid selection in the navigation chapter. The 2 white VOR bearing pointers are now visible. You have seen the 2 raw data displays. Now let's look at the ROSE navigation display. What is now on display is a map view of the area surrounding the aircraft. On the EFIS control panel, the range selector is set at 80 miles, which is the distance from the bottom to the top of the compass rose. The green line represents the flight plan that is programmed in the FMGS. This will be discussed in the autoflight modules. The information contained in the top right-hand corner of the display relates to the to waypoint. In this example, the to waypoint is Papa Alpha Sierra. The information is track 2 waypoint, distance to go, ETA, estimated time of arrival at waypoint. The normal mode for the cruise phase is the ARC mode. Using the push buttons at the top of the EFIS control panel, additional information can be displayed, for example airports that are in the displayed range. A green light illuminates in the push button. On the display, the airports contained in the aircraft's database and within the area are shown. This is a useful feature when considering diversions. All the non-directional beacons contained in the database and within the display range are shown. All the VOR beacons contained in the database and within the display range are shown. The display has started to become very cluttered now that all the waypoints are shown. As you can see, the display is a little less cluttered. Now let's look at the final display mode. In this mode, the flight plan legs are shown on a true north orientated map. The center of the display is a waypoint. The aircraft is displayed in relation to the waypoint. In the example shown, the display is centered on waypoint Papa Alpha Sierra, and the aircraft is heading towards that waypoint. Now let's increase the range to 320 miles. Since plan mode is centered on a waypoint, the aircraft symbol may or may not be displayed. To demonstrate this, we have shifted the display for you and centered it on the waypoint Golf Echo November. Notice that the aircraft symbol has moved towards the top of the display. In this module, we have introduced you to the display modes available and some of the indications on the ND. You will also practice using the various display modes in the Auto Flight and the Navigation chapters, the Flight Management and Guidance Computer FMGC Trainer, and during your simulator sessions.